Welcome you all for today's session, system design using general purpose processor. So here this is the structure of system design using general purpose processor. It is the target processor that probably first come to our mind to anyone writing a computer program. So here it is a combination of both software and hardware, like hardware gates, software programmable, general purpose, application specific. The devices are ASIC, application specific integrated circuit, FPGA field programmable gate array, MUSI, that is microcontroller, and MUP microprocessor, DSP digital signal processor, and also other devices. So here it is a general purpose processor in embedded system. The general purpose processor GPP is used for processing signal from input to output by controlling the operation of system bus, address bus, and data bus which is inbuilt in an embedded system. The general purpose microprocessor make use of von Neumann architecture. So this is the architecture, general purpose processor basic architecture, which consists of memory, controller, processor, and data path. So memory is a storage purpose, and input output controls the entire processor. Program counter, PC represents our program counter, and I/O or interrupt registers, ALU arithmetic logic unit, and registers or the data path unit, and control or status, and next state and logic control unit, and also controller. So totally the basic units are processor, controller, data path, memory, and input output devices. Okay. So here the four general embedded systems types are general computing, control system, signal processing, and communication and networking. General computing is nothing but the application similar to desktop computing but in an embedded package. Example, video games, set-top boxes, wearable computers, and automatic tellers. And control system, it is a closed loop feedback control of real-time system. Then signal processing, the computation involving large data streams like radar, sonar, video compression. Then communication and networking like switching and information transmissions, telephone system, internet. So this is the programmable device which is used in the safety purpose of applications, which is known as microprocessors, which consists of its features of program memory, general data path with large register, and low time to market and NRE costs, high flexibility. So the same units like controller, data path, memory, as well as arithmetic and logic unit, general arithmetic and logic unit. So the ASIC, first one is ASIC, then FPGA, processor, controller, and other device, DSP, etc. Right? Let us have a review of ASIC, that is application specific processors, which is a programmable processor optimized for a particular class of applications having common characteristics like a compromise between general purpose and single purpose processors. Its main features are program memory, optimized data paths, special function units, and the benefits are some flexibility, good performance, size and power, and DSP. Right? So this is the architecture of FPGA, field programmable gate array architecture. So it is a layout with configurable logic blocks. CLB means logic blocks. You can see how the logic blocks are connected by using wiring channels. So the programmable switch at wiring interactions, and IOB is said to be as input output blocks, and CLB is said to be as configurable logic blocks. Okay. And this is the software of software graph that costs proportional to number of units, and it is a hardware to mostly recurring cost, and many mobile phones like highly constrained products tend to use application of this specific processors. And how hardware versus software in system design using general purpose processors, like embedded application specific processors and embedded domain specific processors and general purpose processors. General purpose, here we compare with programmability and flexibility as well as power constraints. So general purpose processors are workstations and personal computers, and embedded domain specific processors or graphic processors, DSP processors and network processors, whereas embedded application specific processors are FFT, MPEG and FAR processors. So these are the levels of embedded system design, like specification, implementation. So here our idea is design abstract with detailed output. Specification is nothing but our design productivity increases with the level of abstraction. The task of functional verification is very difficult at low abstraction levels, and implementation is nothing but it is an efficient requirement to exploit the low level features of the target architecture. And this is the future embedded system, which consists of gateway usage scenario. Will people adopt this other than as a toy? Will the same people who can't set up time VCR to be able to debug their house? So these are all the system, readily accessible, reliable, affordable, right? So this is all about our system designs in embedded system. Thank you all.